Hello everyone, welcome to our second video of the course Engineering Mechanics. In this video, let us learn more about the course Engineering Mechanics. From the first video, we understood that mechanics is a science that describes and predicts the effect of forces on objects that are either at rest or in motion. Now let us see classification of mechanics. Basically, mechanics can be classified into two parts. One is rigid body mechanics and the other is deformable body mechanics. What is deformable body? What will happen to deformable body under the effect of forces? See this object. On this, when a force is applied, there will be change in shape of the object. See again, like this. So deformable bodies, they undergo change in shape or size of the body under the application of forces. Deformable body mechanics, it can be classified into two again. One is solid mechanics and the other is fluid mechanics. Solid mechanics can also be called as strength of materials. Even though fluids and solids both are deformable bodies, we have to study them separately as they behave in different manner under the application of forces. Coming to rigid body mechanics is also called as applied mechanics or engineering mechanics and can be classified into two parts, statics or dynamics. Before going to learn about what is statics and dynamics, what is a rigid body? First, let us try to understand. When forces act on rigid bodies, there will not be any change in size or shape of rigid body. Then what will happen? The objects may change from may shift from one position to another position, or rotatory motion may takes place. So that is about rigid bodies. Now rigid body mechanics can be classified into statics and dynamics. Statics deals with the objects that are at rest even under application of forces, and dynamics deals with the objects which move, which are under motion under the application of forces. Dynamics can again be classified into kinematics and kinetics. In kinematics, we do not consider the force that is causing the motion into account while studying the relation between the properties of motion. But in kinetics, we consider the force that is causing the motion also into account while studying the relation between the properties of motion. Here you see the examples, some examples of statics and dynamics. Here, even after the vehicles moving on the bridge, the bridge remains at rest, and even the beams, slabs, columns of this building, they remain at rest under the application of forces. These two are nice examples of statics, and in dynamics, we deal with the bodies which are in motion, like car, bike, aeroplane, and all those things. So now let us learn about some idealizations in mechanics. We all know that each body is made up of atoms and molecules. Since the behavior of atoms and molecules are too complex to deal with, the matter is assumed to be a continuously distributed object. Such a description of matter is called as continuum. A continuum may be rigid or deformable depending upon the assumptions made. So, rigid body is a body in which the distance between the particles remains same under the application of forces. That means the shape and size of the object is going to remain same after the application of forces also. In mechanics, it is usual practice to assume even a big object like aeroplane as a particle many times because the dimensions of the body here aeroplane are negligible when compared to the distance traveled by the object. Even satellites, Earth, Sun also we can treat them as particles when while studying their motion because the distance traveled by them is very more big compared to their size. So these are idealizations in mechanics. Again, these are the references or websites from which the pictures in this used in this video are downloaded. You can refer them for more information. So thanks for watching the video. In our next video, let us recall the Newton's laws of motion.